This is section 12.2, pyramids. So in 12.1 we looked at prisms. Now we're going to look at pyramids. And first, let's define what a pyramid is. A pyramid is the three-dimensional surface formed by a polygon in a plane, a point outside of the plane, and the segments connecting each vertex of the polygon to that point that's outside of the plane. So I have here a pentagonal pyramid. It's a pentagonal because the base is a pentagon. So this pyramid is labeled V dash ABCDE, where point V is called the vertex of the pyramid, pentagon ABCDE is called the base of the pyramid, the segment from the vertex perpendicular to the base is the altitude, and its length is called H, the height of the pyramid. The five triangular faces with V as a common vertex, such as triangle AVB, or triangle BVC, or triangle CVD, or triangle DVE, or triangle EVA, those five triangles are called the lateral faces of the pyramid. These faces intersect in segments called lateral edges. So the lateral edges are segments AV, BV, CV, DV, and EV. Since the base is a pentagon, there are five lateral faces and five lateral edges, one for each corresponding side and vertex of the pentagon at the base. Most pyramids we will study will be nice pyramids, called regular pyramids. Remember, a regular polygon is one that has equal sides and equal angles. Well, these are regular pyramids, and they have the following properties. The base is a regular polygon, equal sides, equal angles. All lateral edges are congruent. All lateral faces, those triangles, are congruent isosceles triangles. And the height of a lateral face is called the slant height of the pyramid. We call the slant height L, and you see that in the picture there. It is one side of the pyramid. It's the altitude of that face, of that lateral face. And the altitude of the actual pyramid that goes from the vertex at the top to the polygon at the base, that altitude meets the base exactly at its center, which we call O. So we will be dealing mostly with regular pyramids, and you can assume a pyramid is regular unless you're told otherwise. So regular pyramids are very nice to work with. Here's an example of one. This is a regular square pyramid. It's a square pyramid because the base is a square. And it has base edges of 10 and lateral edges of 13. That means the slanted edges that go up to point V are 13. The base edges of the square at the bottom are 10. So let's find its slant height, which remember is L. And let's find its height, the height of the pyramid, which remember is H. Okay, so what's nice about regular pyramids is that we end up with nice right triangles when we try to find the heights. So for example, when we're trying to find L, the slant height, let's use this triangle that is half of one of the lateral edges. That triangle is a right triangle due to the right angle at the bottom. So let me draw it over here. That's not very nice. Let me try again. Okay. Where that's point C, that's point M, and that's point V. We've got a right angle, and MC is 5 because the whole base is 10. We've taken half of that, and then VC is 13, which is the lateral edge. So if we want to find L, that's VM. It's one side of a right triangle. How do we find a side of a right triangle if we know two sides? Well, we use the Pythagorean theorem. We don't know the angles here, so we don't know anything else, but we can find the side using the Pythagorean theorem. We'd say 5 squared plus L squared equals 13 squared. 5 squared is 25. 13 squared is 169. So L going to be the square root of 169 minus 25 is conveniently 144. So L is very nicely 12. So L equals 12. That's nice. And let's then find H. Notice we now have another right triangle, the one that's already shaded in yellow there, that's completely on the inside of the polygon, of the pyramid, I mean, where H is one leg, 5 is the other leg, and L, which we just found to be 12, is the hypotenuse. So that's point V, that's point O, that's point M. So let's find H. Again, we use the Pythagorean theorem, and we say 5 squared plus H squared equals 12 squared. So now 25 plus H squared equals 144. And what is 144 minus 25? Well, it's 119. So H is the square root of 119. That is simplified. There are no perfect squares that divide evenly into 119, because 119 is a prime number. So that's the height of the pyramid. We found the slant height, the height of one of the faces, and the height of the pyramid itself. Now let's try this example. Let's find the lateral area of the pyramid. What do you think the lateral area is? Well, it's the area of all of the lateral faces combined. So it's the same picture. It's still a square pyramid. The base of the square, the side of the square at the base is still 10, and the lateral edge is still 13. So the lateral area is going to consist of the area, or the areas, of the 4 lateral faces, which are all what kind of shapes? Isosceles congruent triangles. So if we find the area of one of them, all we have to do is multiply that by 4, and we'll have the area of all 4 lateral faces, which is exactly what the lateral area is. The area of all the lateral faces combined. So that does not include the area of the base. So let's find the area of one of those triangles. Let me redraw it here. The lateral edges are 13. So the 2 equal sides of our isosceles triangle are 13. The base is 10, because that's the side of the square at the base. L is the height of this. We found L to be 12 earlier. So all I've done is just redrawn essentially one side of the pyramid, one lateral face, which is a nice isosceles triangle that we already know the altitude for. So how do we find the area of a triangle? Well, it's 1/2 the base times the height. It's 1/2 of 10 times 12. So that means it's 1/2 of 120, which is 60. Now that's one face. There are 4. So the lateral area, LA, is going to be 4 times 60, which is 240. To find the lateral area, we really have 2 methods to find the lateral area of a regular pyramid. First method is the one we just used. Find the area of one lateral face and multiply by the number of lateral faces, which is n, which is the number of sides of the base. The square, that's 4. So we multiplied by 4. The second way we can find the lateral area is to use the following theorem. The lateral area of a regular pyramid equals half the perimeter of the base times the slant height, which we called L. Half the perimeter of the base times the slant height. So, in this example up here, the perimeter of the base is 4 times 10. It's a square. Each side is 10, so there are 4 of them, so the perimeter is 40. And then the slant height, L, was 12. So the area would be 1/2, or the lateral area, sorry, would be 1/2 of P times L, which is 1/2 of 40 times 12. Half of 40 is 20. 20 times 12 is 240. So that's another way we can find the lateral area. If we know the perimeter of the base and we know the slant height, we can multiply them together and then take half of that. A very useful formula that you need to memorize. Now what about the volume of a pyramid? How much space is inside of the pyramid? Well, we already know how to find the volume of a prism. We said the volume of a prism is simply the area of the base times the height. Capital B is the area of the base, and h is the height. So if we know the area of the base, we can multiply that by the height, and we will have the volume of the prism. A pyramid with the same base as a prism, so if I have the same regular hexagons as the base of my prism and my pyramid, the pyramid is clearly smaller than the prism with the same base and the same height. We can in fact fit the entire pyramid inside of the prism. So it's smaller, so the volume is going to have to be smaller than B times H. In fact, it is exactly 1/3 of B times H. 1/3 of the area of the base times the height. And that's this next theorem. The volume of a pyramid equals 1/3 the area of the base times the height of the pyramid. So in fact, I've typed this wrong. It should be a capital B. Let me change that. There we go. 1/3 the area of the base times the height of the pyramid. So let's use that here. If the regular hexagonal pyramid at the right has base edges of 6 and a height of 12, find its volume. So it's a hexagonal pyramid. That means the base is a hexagon, a 6-sided polygon, and we know it's a regular one, so all the sides are equal. It has base edges of 6, so each of those base edges is 6, and a height of 12. H is 12. Let's find its volume. So we know H is 12. We need to find the area of the base, and then we'll multiply those and take 1/3 of it. So let's find the area of the base. That means we're just going to be working with the base, which is a regular hexagon. I'm going to draw one, rather crude one. That's not very good, but we'll take it. Bases are each 6, or the sides are each 6. We want to find the area. Well, how, from last chapter, do we find the area of a regular polygon? And we did a lot of hexagons. We take 1/2 of A times P, where P is the perimeter and A is the apothem. So let me draw the apothem. It goes from the center, it's perpendicular to one side, and that makes a nice 30, 60, 90 triangle. So focusing on that 30, 60, 90 triangle, this is going to be 3, half of the side length. We've got 3. There's a 30-degree angle, there's a 60-degree angle, so that side is 3 radical 3, and that side is 6. So the apothem is right there, it's 3 radical 3. What's the perimeter? Well, one side is 6, there are 6 of them. But 6 times 6, which is 36. There are 6 sides because it's a hexagon. So we've got the area of the base, which really I should call B here, capital B, because that's what we're going to be using in the formula. Capital B is the area of the base, which is 1/2 of A times P. So that's 1/2 of 3 radical 3 times 36. So half of 36 is 18. 18 times 3 is 54. So we've got 54 radical 3. It's our capital B. 54 radical 3. And h is 12. So let's plug those into the formula for the volume. The volume is 1/3 of capital B times h. It's 1/3 of 54 radical 3 times h, which is 12. Okay, well, 1/3 of 54. 54 divided by 3 is 18. And 18 times 12 is 216. And we've got a radical 3. So 216 radical 3 is the volume. All I had to do was find the area of the base, which was a regular hexagon, and multiply it by the height, and then take 1/3 of that. So your immediate practice problems deal with a regular square pyramid. Square is nicer than a hexagon. If the base edge is 6, so that is 6, that's 6, and those two sides in the back are 6, and the lateral edge is 5, so this is 5 here. Find L, H, the lateral area, the base area, and the volume. To find L, you're going to do like I did in the first example and use the right triangle formed over here. To find H, you're going to use the right triangle drawn in red in the middle. Once you've found L, L will be the hypotenuse of the triangle you're using to find H. The lateral area, you're going to find the area of one of the faces and multiply by 4. The base area, you're just going to simply find the area of that square at the base. That's the easiest one. And then the volume, you're going to use the formula 1/3 of the area of the base times the height. Make sure you draw the picture and show your work. That's the end of section 12.2.